is a tubal pregnancy when it's fertilized within the fallopian?
Well, normally it is always fertilized in the fallopian tube. The trick is normally it comes down to the uterus and implants. Tubal pregnancy is it stays in the tube.
Okay, that makes sense.
So it's tubal conception is the number.
Yeah.
Contain.
Alright, so let's go down through your charts. Okay, so again, we're going to pretend we're male. We're just going to travel our way on out. So let's go to our chart and fill in our pathway of sperm land here. So tell me what testes are for. Make sperm, sperm factory, spermatogenesis. Sperm makers. What else do they do? Make hormones. So you can say make sperm, make hormone. What hormone is it? Testosterone. Notice testy, testy, testy. Testosterone, testes. That's the name. Testosterone. So make sperm, make hormone. Male factory. All right. Is it inside or outside? Is internal. All right. Let's figure out why. There's a quick answer, which is you can't actually put your finger on your testis. All right. You can put it on your scrotum. But there's actually a more formal answer. Let me show you a picture showing why it's inside of you. And that has to do with baby boys and their testes descend. So you have to think about this picture is a little later. So when you were an infant, when I was an infant, my testes were up basically toward my kidneys somewhere. And then as you get older, they hence drop, descend. Here they come on down. And they end up at some point in your scrotum. Okay? But if you usually at birth or within a month of birth. So it can be slightly before, slightly after, but usually that's when the doctor sort of feels in there and checks babies, make sure they're descended.
And what's these swollen, like the swollen when they're born?
That's a homework question for next week.
Okay.
Yes. So let's look at this picture one more time. So if you look at the testes, okay? Here's my peritoneum in pink. That's the membrane around my intestines that you learned a couple weeks ago. Okay? If you look at this, here's my peritoneum. And then here's my basically part of my peritoneum. So my testes are still located in around the peritoneum. My peritoneum now is in my scrotum. So they're still formally inside my body cavity. My body cavity now lives in my scrotum.
Does it separate and like
yes.
It's not continuous anymore?
Right. So the peritoneum then seals off, but what was in the peritoneum stays here. And you know this because what's that funny disease that men get if they strain too much? Hernia. So what happens in a hernia?
Lining rips.
Something rips, right? And the intestines come down in their scrotum, right? Because there's a hole there. There's nothing blocking the testes and the intestines from being together. It's their friends, right? So in a male, the testes are basically still part of the abdomen cavity. There's still a hole between them. They're not separated by anything. So they're formally still inside the male. Plus you can't put your finger on it. That's another definition. Make sense? So they're still considered internal organs because they're inside the body cavity. Right? We're this trivia in lab next week. It's called a tunica vaginalis, which is a silly name for a boy. That means to pooch in the layer. So basically, you push your intestines into your scrotum. Becomes your tunica vaginalis. Make sense? So they're inside you, inside me. Right? Let's go back to our chart. So, epididymis. Sperm house. We can put that. Sperm school. You can put that. Maturation of sperm. Mature. So sperm go there to grow up. They go there to learn how to swim, to be friends, to gang up, whatever. But they're going there. They're made in my testes. They're juvenile sperm. They end up in my epididymis to grow up and be mature sperm. Right? Is my epididymis inside or outside? I'm going to say it's internal. If you look at the picture of my epididymis, one more time, which is here. Where's my epididymis? There it is. No, that's right. My epididymis. This is my testis, this big, round thing. That little slug on the golf ball, the Roman helmet, they call it, that's the epididymis. Where's the shit is? Anyone know literally what epididymis says in medical terminology? On top of what's your didymis? Anyone know? Thomas the twin, the apostle, didymis means the twin. That's on top of your twins. Really, epididymis means on top of your twins. That's what they got today. They'll never figure where they are.
That's clever.
Literally, on top of your twitters. Right? Okay, so that's on inside of me is on my testicles. Then we have the scrotum, which is next in your list. So if we go back to our list here, we have a scrotum. What is the job of a scrotum?
Control.
Temperature control. Thermoregulation, blah, blah, blah. The temperature control, hence the cold shower effect. Okay, so you get cold, the thing pulls up, they get too hot, they pull down. So the job of the scrotum is to keep the sperm cool. So you want cool sperm.
External.
And that is external because it's skin. I can touch it. It's outside of me. Whereas the shittiest sperm have to be at least 2 degrees less than body temperature to not die. So that job of the scrotum is to keep them slightly less than body temperature. Where those shitty hot tubs do make you sterile. Don't use it as a contraceptive method. They do that.
And a fever would do that?
Fever will do that too.
And then in most cases temporary.
Yeah, it usually lasts about 2 weeks. Again, do not try contraceptive method. Okay, so now we are on to the vas deferens, also called the ductus deferens. Same thing, different name. So vas is from vaso, meaning tube, deferens because it's deferential. This big thing here. So what's the job of the vas deferens or the ductus deferens? Sperm something, right? Sperm highway. Sperm highway, sperm freeway, the sperm I-5. Alright, sperm tube. I-5 for sperm. I don't care how you remember it, right? As long as it's sperm tube. Right? So if you get a vasectomy, right, they're cutting the highway so sperm can't go anywhere. That's the concept. So they're made, but they can't go past what's in this. So vasectomy.
So where do they go?
They go nowhere. They just stay in their school.
They just stay there. They don't.
There's never like a builder.
No, eventually they die. Your body eats them. The white blood cells chew them up, and you make more. They do ejaculate. They just don't have sperm. All the stuff upstream, downstream. Yep. Is your vas deferens inside or outside? It's internal. Okay, let me show one thing. This is my kind of pet peeve, hang up, I guess. If you look at this picture, every biology book does this picture the same way. It's just people ask me what kind of does first. It looks as though your vas deferens kind of goes through the middle of your bladder. Okay? Which it doesn't. If you remember lab, that's not anatomically correct. If you draw it that way, you have to look basically from the rear to notice that it goes on the outside of the bladder, one from each side. And they kind of merge together, but when they do it from a side cut, they're trying to show that turn by putting it through the middle, like that. So when you get the lab right, it's not going through your bladder, it goes around the bladder. They just draw it, I don't know. On this picture, it would be vanished behind that. Makes sense? Just my own pet peeve is they always show up that way. I didn't go through my bladder. It doesn't. It goes around the bladder. There's one from each side. So you're getting vas deferens, ductus deferens. As you come around the bladder, there's a little gland, sometimes called a vesicle, right there. So gland number 1 is the seminal vesicle. We go back to our chart. Right here. What's the job of a seminal vesicle? Mix fluid.
So it's the seminal vesicle, the same as the seminal gland.
Yes. Although the formal word I learned was vesicle. Makes fluid. That's part of the fluid. Which we'll talk about the fluids in detail. So seminal fluids make seminal fluids made in the seminal vesicle. So it's a gland. So it makes some fluid. We'll talk about that later. So is the seminal vesicle inside or outside? It's inside. It's behind your bladder. It's a hard place to find. It's inside. That leaves us with Mr. Prostate. So if you go back to this picture, right here. So remember in lab, the prostate was under the bladder of the male, the prostatic urethra. Right? It's the next thing in the way. So we go back to the actual cause of the gland. What do glands do? Make fluid. Secrete fluid, make fluid, produce fluid. So again, it's a gland. And is it inside or outside? Prostatic exam, let's stick a finger inside of you. Alright? It's inside. That leaves us gland number 3. This little guy right there. The base of the prostate where the membranous urethra was in lab was a bulbourethral gland because it's a bulb near your urethra. That's what they named it. The old word was Cowper's. You may have heard Cowper's gland. That's what they're talking about. And that's why bulbourethral is the third gland of the 3. What's the job of what do you think that gland does? Take a guess. Make some fluid. Again, we'll talk more about the fluid. So we're making fluid. Inside or outside? Internal. Okay, I like glands so far? Next up, let's see if you follow the money here, around, behind, zap, zap. Hey, I'm in the urethra. Hey, I'm coming out that thing. What is that thing? That's the penis. Last time I checked. So now we're up to the penis. Alright, this one was good for last night's test. What's the job of your penis? Copulatory organ, you could say. Organ of sexual intercourse, organ of penetration, missile, whatever. Copulation.
Missile works.
Missile works, right? Male hobby, right? Make something. I've never asked, tell me what your penis does. Is the penis inside or outside? It's outside. What's the point, right? If it's inside, right? It's external organ.
It's also urinary, isn't it?
Yes. In this case, it's in the urethra. So then we have these things: corpora cavernosa and corpus spongiosum. Okay, cuts the penis in half.
Oh God.
We need a All right, so inside your penis, my penis, someone's penis, we have these bodies. Corpus means body, and just to be funny, cavernous means tall, cavern, and spongy means spongy. Remember, spongy urethra was one of the words you learned. So these are the tubes within the penis, within structures within the penis. So if I do a different view of that, which is the view, so the penis clown. No. Penis monkey. People call that monkey face, capuchin monkeys. They're never looking similar. No. It's wrong. Surface delay. So, these are the 3 tubes, the 3 structures within the penis. So, cavernosa, the taller ones, the bigger ones, the eyes of the clown, and spongiosa, the mouth of the clown. Okay. So, let's go back this way. So, what is their job? Why do you have those? These are erectile tissues. We go back to our list, they cause erections, erectile tissues. So, erections. So, are they inside or outside? Yeah, so here's one of these weird ones. You can't physically touch them, but they are part of the penis, and as such, they're considered external. So I know, yes, I can't put my finger on a person's spongiosum, but the idea is they're just penile parts. So they count as penis parts. Make sense?
What kind of tissue are they?
Well, they have a fascia, which is connective tissue, usually a dense regular, and then they have areolar as part of it, which is more basic, it's spongy. And then there's a blood vessel in the center of each one. And I think there's one more connective tissue that's escaping me at the moment. But basically, it's a sac of areolar with a fascia on the outside. And a blood vessel inside. Do you understand our basic parts? Okay, so now we're going to zoom in on some of these parts before we answer the question. Let's go back to how we make sperm. And where do you make sperm? Testes. So we have to learn about making sperm. So I'm going to show you some pictures. Zooming in on my testes. And no, I do not know why there's a drip coming off the epididymis. I did not draw this. This isn't me. Right? But here's my testis, one. Here's the epididymis, the sperm school. Here's the tube going up in my body. So what do you see there? What are those little things there? Say this word there. Seminiferous tubules. So for our notes, we're going to start breaking down my testes. So testes contain so the fancy word is seminiferous tubules. What organ 2 weeks ago was an organ made of a bunch of tubes? The kidney. Remember, that's the nephron. That's the same concept here. We have one organ that basically has a bunch of tubing inside of it for a different reason. So the testis that you call a testis, actually a bunch of little tiny tubes inside the testis. Why do you want tubes in a testis? Glad you asked. Here's the picture. So what you notice at the very center of the picture, what are those things? Those are sperm cells, spermatozoa, sperm, take origin life. And what are we doing? Well, there's no sperm over here. There's sperm here. We're supposed to be making sperm. So formally, the tubules are where you produce the sperm, not the testis as a whole. It's the tubes inside the testis that make sperm. So we need to go through now and figure out how you make sperm in your sperm seminiferous tubules of your testes. I'm going to show you some pictures. I'm going to change it slightly. Like this. So this is showing 4 of the seminiferous tubules, 4 of the tubes in your testes. So here's one of them up close. And in theory, you remember all this from 112. I know the answer, you have no clue. But remember meiosis?
Yes.
What was meiosis about? 112. Sexual reproduction, you have your chromosomes now and increase variability, right? So what we're doing here is we're going from a diploid cell, mother cell you learned in 112. You're going meiosis, because I highlighted it in blue, and you're doing meiosis to make haploid gametes for sperm. Right? So your seminiferous tubules are where you perform meiosis. You make sperm via meiosis. If you don't remember the steps to meiosis, retake 112, right? PMAT times 2, all that fun stuff. So today, you don't have to know those steps. You just have to understand that I'm doing meiosis, going from a diploid mother cell to a haploid sperm in my seminiferous tubules. Make sense? Nod your heads. Okay, so now here's my question for you. In this picture here. They highlight basement membrane. That's important enough for someone to put on this picture. Why is there a membrane here? Let me show you another view of that same membrane. Okay? So in every picture you're going to see of the testis, they highlight a basement membrane around your seminiferous tubule. And if you look carefully, there's a complete ring all around this tubule. It's separated from the rest of the body. Why would you want tubules separate from the rest of you? Go back to last term immunity. Protects against pathogens and
You're autoimmune.
autoimmune. Let's go back to what we learned in our immune system.
Body thinks it's not self.
That's right. These are haploid, they're not you. So your immune system thinks these are invaders, right? They're not me. So every seminiferous tubule is surrounded by a blood testis barrier. That's that membrane that we were showing you. Because what are you trying to keep out of your testes? The blood. And what's wrong with blood? The white blood cells, right? So it's to prevent immune response. Because of meiosis, my sperm are not me. My body would see that and kill my own sperm off because they're invaded. Remember the MHC stuff? Vaguely? That's the concept here. So every seminiferous tubule is going to have a barrier between the sperm, which are not me, and my blood, which is me. That's called the blood testis barrier. Saladin goes on for like pages on this. Right? You keep the blood and the testes apart. So another way to say this is immunoprivileged. Your testes don't get attacked by the immune system.
Is the ovary the same?
Yes, ovary is the same. So is your uterus when pregnant. Question?
So,
Yes.
so if you were to get an infection, would it be hard to fight?
No, but, well, yes. So if you get something within the seminiferous tubule, the immune system can't locate it. Right? So things like testicular cancer and stuff are a problem because there's no way your immune system can see it.
Mm-hmm.
The worst, the more common problem is if you break that barrier. So let's say someone's nice enough to get the nuts, right? All right, let's go through that. But then is going to do that, right? Let's say you have trauma and someone busts that barrier with a kick, a dodgeball, whatever, a knife in the side of a bar. Okay? And now blood begins to leak into your seminiferous tubule. What would your white blood cells do if there's a hole in that basement? They're attacking. So you can get immune response destroying your own sperm, destroying your seminiferous tubules because they're not longer separate.
If someone had a problem with their basement membrane, is that how men become sterile?
It is one way.
Is that the most common way?
I don't know if it's the most common. I've never heard of commonality, but it does happen. You're again at blood testis barrier. So now what we're going to do is try to figure out one more component, which is, if there's no blood contact, how does my body know how many sperm there are? I mean, my blood's not touching my sperm. How would I know how many sperm there are? Hormonal control. Let's learn hormones of reproduction of males. So to understand how I control my testes, believe it or not, you have to understand the hormones of the male reproductive system. And that relies on you understanding that picture again. So here's another view showing my seminiferous tubule. So again, the barrier's out in the top. These are the sperm in the bottom. And I'm making sperm as I go from top to bottom. Okay? But there's no way for my body to notice what the sperm are doing because there's that barrier. So instead, your sperm have to make a hormone to tell the body what they're doing. Right? So what we're going to do is go back a little bit and review our male reproductive hormones and go to the last term. Remember them at all? Not at all. Yes, remember those? FSH and LH. We're going to review 232 one more time. So we're going to make a big page-long thing of some hormones over here. We're going to walk through those again. Fill in the details. Yes, we're going to add those over here. So, last term, you learned you had the hypothalamus. The hypothalamus made hormones that affect that organ there. What organ is that right there? That's my pituitary. Which pituitary was it? The anterior pituitary. So my hypothalamus gave instruction to my anterior pituitary. Or adenohypophysis, if you prefer. Then you remember vaguely that my anterior pituitary gave orders to the organs, which would be my testes in this case. Remember that chain of command stuff? All right, so now you have to dig deep in 232 and try to remember the hormone that my hypothalamus tells my pituitary to talk to my gonads was. GnRH. What does that stand for? Yay! I taught you something. Gonadotropic releasing hormone. Remember releasing hormones are made by my hypothalamus to turn on my pituitary. So my hypothalamus makes a GnRH, which on a test is fine. Right? So if I scroll up a little bit, here's my hypothalamus brain, and they just call it releasing hormone, but they mean GnRH. GnRH goes from my hypothalamus to my anterior pituitary, my genohypophysis. My pituitary then makes the tropic hormones, LH and FSH. So my pituitary is going to make LH and FSH to go to my testes because they're tropic. Remember that big concept? They turn on other glands. Okay? So I have a GnRH, a releasing hormone from my hypothalamus. I have tropic hormones from my anterior pituitary. And I have the testes, which is the worker who's going to get these messages. Make sense? Okay, so I'm going to change my picture slightly. I'm going to draw a V for my LH to one side, and my FSH to the other. Still going to the testes, but I'm going to split them up because they have two different jobs. So, does anyone remember from last term? Didn't have to do it then. Do you remember meaning the difference between FSH and LH?
One stimulates the production of
Yes, one does. The other one does production of? Well, sex hormones. Let's see. FSH spells fish. Fish have tails. Sperm have tails. Therefore, FSH tells me to make sperm. So FSH is the tropic hormone that tells my testes to make sperm, or spermatogenesis. Because fish have tails. It's a silly way to remember, but it works. So I'm stimulating my follicles, which means I'm going to make sperm. So FSH will tell my body to produce sperm, testes to make sperm. What else do testes make besides sperm?
testosterone.
Testosterone. So LH tells my testes to crank out testosterone, to make hormone. So LH is testosterone. So one hormone for sperm, one hormone for hormone. Oh wait, there's a subtle nuance here. If you look back on this picture, back up here. Do you notice the sperm production I need FSH and what else? I need LH via testosterone. So I need testosterone directly to make sperm. So if I were to make this complete, I would draw an arrow like that as well. So the testosterone is also needed to make sperm. I can't just use FSH. I have FSH plus testosterone via LH. Make sense? Okay. So we're going to make a graph over there. You know that's coming, right? Let's make a graph. Let's do testosterone over time. So let's say you don't have any testosterone today because you have 4 kids on the farm. All right, so what would my hypothalamus think of this if it doesn't think you have enough? Tell me to make more. So what hormone would kick in? I'm going to increase GnRH. My hypothalamus, my CEO would say, I need more hormone. Give me hormone. So middle management, Mr. Anterior Pituitary, would make what hormone? I'm going to increase LH. And LH tells me to do what? Make what? Testosterone. So my testosterone levels would climb because my managers are yelling for testosterone. Make sense? Let's say somehow I end up with too much testosterone. Don't ask me out. What would my brain think if there's too much of that? Lower GnRH. I'm going to turn off GnRH. That would tell me to make less LH, which tells me to do what? Make less testosterone. So testosterone would be a simple negative feedback kind of graph. I don't have enough, I make more. I have too much, I make less. Right? Okay. We're going to do the same graph again. This time we're going to do sperm number. One more time. You know how this is going. So if I don't have enough sperm, what will GnRH do? Increase. It's going to tell me to turn on more of what? Yeah. FSH directly and LH indirectly. FSH tells me to make sperm, and LH tells me to make testosterone. So I might see both go up. All right? Now tell me to make more sperm. If I have too many sperm just hanging around, what's going to happen to GnRH? Go down, which is going to shut off my fish and shut off my LH to lower my testosterone, to lower my sperm, so my sperm levels go down. Also negative feedback graph. Let's go back to the question though. How does your brain know how many sperm you have? Sperm don't go in my blood. Let me show you the magic answer. Actually, no. You think it would be testosterone, but it's not. Really. Let me show you this picture right here. This is the formal picture. So here I have my hypothalamus, my brain. Here's my hypothalamus saying, give me sperm, I want sperm. So GnRH comes out, yells at the anterior pituitary, it says, thank you, sir, I'll make you some more. So I'm going to get FSH and LH. LH tells me to make testosterone, which is necessary, with FSH to tell me to make sperm. That's the graph I just showed you. You look over here in the red line, though. You will see this red line has a name. What name is it? Red? Inhibin. So, we're going to add another hormone to our list. That's inhibin hormone made by sperm. So the sperm can't go in my blood, but they can make a hormone that does. And from the name inhibin, what do you think inhibin does? It inhibits. It's going to turn off my brain in this context. It's negative feedback. It turns off or inhibits or disactivates, whatever, downregulates, pick a word for.
Does it deregulate? Does it do that to the GnRH?
Yes.
Where does that occur? What is it making? What is it?
It's made in the sperm, actually. This is the macular cells in sperm.
And how does it get to the blood to get?
It crosses that barrier, and then it gets a little bit like yes, hormones. So the sperm are in the blood, but I can measure the hormones in the blood.
So is inhibin a steroid?
Yes. Actually, hold on. I'll get back to that. Yes.
How does the inhibin get into the blood if there's that barrier for the immune?
Because it's not a cell. It's small enough it can pass through the barrier, but the cell's immune system cannot.
Either actively or by.
Right. So there's no receptor. The cells are too big, just like the kidney. But a hormone, same reason testosterone, same reason LH and FSH can get in. They're small enough to pass through the barrier, but the immune system actually can't.
So does it reach a certain amount before it releases it, or?
It's constantly being released. So every sperm is cranking out basically inhibin all the time long. As that level climbs up and up and up, it tells your brain you have too many sperm, time to shut down. So on this graph over here, we're going to add the inhibin levels. So if my sperm are low, what's my inhibin going to be like? Be low inhibin. Therefore, I'm not going to inhibit my brain. My brain would turn on to make more sperm and testosterone. If I have too many sperm, I need to turn everything off. That means my inhibin levels are high. Now I have to have inhibin because that barrier that keeps the cells out of my brain. You don't want sperm floating around in you. So the inhibin levels are basically the negative feedback part of this. Make sense? All right. So let me show you then, if you understood that concept, let me show you an animation of that. We got a naked guy on the screen. Always good for us. All right.
Hormonal mechanisms that influence male reproductive function involve endocrine tissues contained in the hypothalamus of the brain, the anterior pituitary, and the testes.
Remember our axis, pituitary, testes axis.
In the hypothalamus, certain neurosecretory cells secrete gonadotropin-releasing hormone. Gonadotropin-releasing hormone is carried by the blood to the anterior pituitary, where it binds to receptors on gonadotropes and stimulates the cells to increase secretion of two gonadotropic hormones, luteinizing hormone, or LH, and follicle-stimulating hormone, or FSH. LH and FSH are transported in the blood to the testes. LH and FSH both indirectly affect spermatogenesis. LH binds to receptors on Leydig cells between seminiferous tubules and stimulates the secretion of testosterone.
So again, LH does the testosterone job of the testes. So turning on, fancy word is Leydig cell, but that just means testosterone cells.
Under the influence of FSH and testosterone, Sertoli cells produce androgen-binding protein. ABP binds to testosterone and maintains high levels of the hormone near the spermatogenic cells. Under the influence of testosterone, Sertoli cells nurture the stem cells and the developing sperm cells. Testosterone stimulates the final stages of spermatogenesis. In addition, testosterone is converted into dihydrotestosterone, another hormone that may promote sperm cell formation. Testosterone and dihydrotestosterone both bind to the same intranuclear receptors. Together, the androgens regulate male prenatal development and the development of male sexual characteristics.
Hence, male sex hormones, quick and dirty, or androgen, you learned last term, or steroids. But basically, it's because of this. Once I have those being made by my testes, I'm going to be boy in my biological development. Click on this fertility cell. That was here. Which was it? There it is.
Sertoli cells release the protein hormone inhibin when the level of spermatogenesis required for male reproductive functions has been attained.
So let's read that again. Right? So Sertoli cells are the ones that are helping make the sperm. They release inhibin, it's a proteinaceous hormone, right? That affects when you have too many sperms. When you have enough sperm, you're going to shut it all off. So you can't blow up, right? Like some 8th grader would say. And you can't. You shut down. Eventually, when you have too many sperm, just mill it around. See?
Inhibin is delivered by the blood to the gonadotrophic cells within the anterior pituitary.
Okay, so in case you yellow, there are actually two red lines on most overheads. Some, it will inhibit the anterior pituitary, also inhibit the hypothalamus. The entire management structure will be inhibited. So I don't care if you say the hypothalamic or the pituitary is going to turn off the brain part. Right? However you want to do that.
Inhibin acts on the gonadotropes to reduce FSH secretion and thereby decreases the rate of spermatogenesis. Similarly, testosterone acts in a negative feedback manner on anterior pituitary gonadotropes to suppress the secretion of LH. The negative feedback effect of testosterone also involves its effect on the hypothalamus, the result of which is decreased secretion of gonadotropin-releasing hormone. Decreased secretion of gonadotropin-releasing hormone causes a corresponding decrease in the secretion of both LH and FSH. The decrease in LH causes a decrease in the secretion of testosterone by the Leydig cells in the testes. Low levels of testosterone reduce spermatogenesis. Conversely, an excessive decrease in testosterone allows the hypothalamus to increase its secretion of gonadotropin-releasing hormone. This secretion causes an increase in anterior pituitary secretion of LH and FSH. and an increase in secretion of testosterone by the testes.
Still negative feedback. You don't have enough, I'll make more. When you have too much, I'll shut it down. It's a very simple system. Right? So just to show you, I'm not making this up much. We show you a graph, which is here. So this is a graph showing serum concentration of testosterone over unit time. So this is more just gee whiz, aha moment than anything. So if you notice this graph, the testosterone levels vary over what period of time? What is this down here? Over the day. So unlike females who learn which vary over a month, right? Your menstrual cycle is monthly. Men have a daily rhythm. So our testosterone goes up and down along with our sperm day by day. So every day your brain's and worthless trivia, when is testosterone the highest? Yeah. So next thing in the morning, wouldn't wonder why. Your brain is horny as anything just before 8 a.m. Your testosterone is the highest it will be. You're the most testosteronic then. And then after dinner time, you crash.
So that's the best time to conceive.
Absolutely.
Or not?
Well, conception varies, but men are the most horny in the morning.
Is this just assuming that you're sleeping at night?
Yes, it's assuming that you're circadian, right? So testosterone is used partly for muscle development, so you burn it as you go throughout the day, and then you recharge it.
I heard somewhere that after alcohol consumption, testosterone builds up in the body.
I've never heard that. I've never actually gone with that. I don't know.
All right.
Right, so make sense? So that's partly to show you though that it's daily rhythm. Whereas menstrual cycle, which we'll do probably next week, that's over a month. So one difference between male and female brains is how they monitor the levels of these hormones throughout days versus months. So there's a difference in timing. So let me show you one more little animation. So I know you love that stuff, right? We're just making this part.
Sperm formation in the human male takes place in the testes, which are contained within sac-like scrotum. Inside of each testis are diploid cells called spermatogonia, derived from embryonic germ cells.
Okay, worthless trivia. Gonia just means I'm gonna make it. That's what but a gonium is a part that will eventually make something. So spermatogonia in kind of cheap English here, making I'm gonna make sperm. Yeah, that's really, well, honest to goodness, that's why we say that.
Spermatogonia can divide by mitosis. In this way, a continuous supply of spermatogonia is available. During embryonic development, hormones stimulate some of the spermatogonia to form primary spermatocytes. At puberty, increased production of the hormone testosterone stimulates meiosis 1.
Ooh, testosterone. We need testosterone to make sperm, right? So you hit puberty, you start making hormones, because your brain wants you to, and that tells your testes it's time to start making sperm. So you're going to start cranking out meiotic sperm products here.
In this first meiotic division, a primary spermatocyte generates 2 secondary spermatocytes. Each,
Yes?
Do you produce seminal fluid before puberty?
Not in a real way. Usually puberty is when you formally get going through the secretion. In a real
secondary spermatocyte then undergoes meiosis 2. In this second meiotic division, both secondary spermatocytes generate 2 haploid spermatids. The result is the production of 4 haploid spermatids, 2 from each secondary spermatocyte.
Remember that from meiosis, you always get 4, that concept. So I do meiosis after puberty because my brain tells me to, and then I start cranking out 4 sperm at a time for every spermatogonia. So I'm cranking out lots and lots of sperm. But wait,
These spermatids eventually mature into sperm cells. Thus, during spermatogenesis, one diploid spermatogonia gives rise to 4 haploid sperm cells. The sperm cells produced in the testis are stored in the epididymis. They complete their maturation there.
that's not to scale. But I'm making them in my testes. They go to school and grow up in epididymis. They learn to swim. It takes a couple weeks for them to do that. And now I'm going to have mature sperm. But the testes did it first, made them. You pass them along to the nanny of epididymis. There is it. There they are. So if a man is not ejaculating a sperm, that in theory is what you'd see. Is the sperm would just be hanging out in school, and then the body would realize I have too many because I'm making inhibin, and therefore the brain would say we don't need any more, so these ones go away or die or you ejaculate, and then we'd restart the process the next morning and do another round.
They can't like build up.
You will not blow up, you know.
That's not what I'm saying. No one said build up, one said blow up.
Yeah. They build up to a point, and then the brain would either. So where's the thing? So they build up, inhibin levels decline. The brain has two choices. I'm going to shut them down, and I'm going to make you really, really horny. So the concept of the brain is I want them to reduce the number one way or the other. So either you're going to have sex, or have nocturnal emission, or whatever, or they're just going to sit there and make you miserable. Yeah.
So if you have a vasectomy, would your testosterone levels then go down because it's not leaving the situation?
Right. So what happens is, right, so eventually the brain's shutting that down more and more, but in the meantime, the brain's trying to get you to get rid of them. So what happens is then, as the levels climbing, they're sort of getting horny with it, and then eventually either the brain would turn off your sex drive, or you lose the sperm, or shut down production. So you get this kind of daily, I'm horny, I'm not kind of.
It doesn't happen when you have a vasectomy.
No, vasectomy, the brain still thinks you have sperm, because you still have sperm. They just don't come out. So the brain's always here. Because they never go anywhere. And so the brain would just be there. The brain doesn't know that, and vasectomy just thinks you never have sex.
How long does the sperm live?
About a month. It's about 2 weeks to make them, about 2 weeks to mature. They live about 2 days after ejaculation, so a month-ish. Give or take. In theory, yeah.
So less sexy now.
Yes. At the end.
What did you ask?
Yeah. More sex makes you more.
Makes you more money.
Yep.
More sex.
Your brain would keep asking for more.
When you say proliferative, you mean like inside of something? Not just like on a table.
Right.
So if we're not thinking
Not on a table top, no, like any female.
You just basically asked if you ejaculate.
All right. Let's get back to this. Okay, we figured out the sperm thing, right? Question 1. We have glands. So notice the phrasing here. They don't make sperm. So please don't put your prostate makes sperm. I'm going to laugh at you as I dig up the point, right? They make fluid, right? So now we got to figure out the fluid and why you need fluid. I mean, why isn't sperm enough? Let's talk about your seminal fluids. We'll do each gland individually and talk about the fluid they make. So let's learn them again in order. What was the first gland in the pathway? Seminal vesicles. My glands. Then the second one was the prostate. The third one was, well, I'm going to say BU, I get sick of writing. But these are the glands, they make fluid. They do not make sperm. So let's learn some vocabulary real fast. So, this thing here, with a tail, what is that called again? That's a sperm or sperm cell, spermatotid. The fluid is called seminal fluid or fluid. So if you take sperm and add the fluid, which is here, what do you make? Semen. Not the sailor guy, different speller. So there's two components to the ejaculate fluid, which we can call this ejaculate. You have the guy with a tail, and you have the other goop that's floating in. They're not the same part. So testes make guys with tails, but these make the goop they're floating in. Right? So we have to learn what each part is. So seminal vesicles make fluid. What's in the fluid they make? Fructose, or sugar. Besides a bad joke, why is there sugar in there? Energy for the sperm, ATP. What else does it make? Prostaglandins, so some hormones. It makes a buffer. Ooh, why would you want a buffer? Yeah, acidity of the vagina, acidity of the urine. Acidity is not so good, right? And a clotting agent. Okay, we're going to stop on that one. Why do you want a clotting agent with your sperm? So it's not so liquidy. Why would you want liquidy? You're a biped. Think about this. So it won't run down your leg, right? Gravity. You want the sperm to stay where you put them if you want the sperm to actually find an egg. So you're going to have to make it stay thick so the sperm don't liquefy. So there's a clotting effect. Let's go to Mr. Prostate. What's the prostate make? Fluid, I know that. Okay, we'll do something. Makes an activator. What does an activator tell sperm to do? Start swimming, because that's what they do when they activate. They start swimming. We got some more buffers. Can't go wrong with a buffer. Right? And I say this, a clot buster. Now, why do you want a clot buster? You just clotted. Why do you want something that unclots? So they can swim. So this is a really peculiar system. You want them to thicken up to stay there. But if they stayed there, they would never get to the egg. So you want them to unthicken up eventually to find an egg. So your seminal fluid does both. It clots it, and then it unclots it. There's actually a time delay of 10 minutes between them. Worth the trivia. But they call it liquefaction. So they have to stay there, and they have to unstay there. Be able to get, they have to basically stay in the vagina, and then be able to swim to the uterus. So it requires both of those. Two different glands do two different jobs.
The clot buster
Yes.
is affecting the seminal fluid.
Yes.
Once it's in the vagina.
Yes. 10 minutes after ejaculation. Or anywhere else. Yes. So it thickens up and then it unthickens. Bubbly urethral gland. Mucus, and the mucus tends to be buffering. So we'll put both down. Again, why do we need so much buffer? Vagina's acidic, urine's acidic, acid kills sperm. Sperm don't like being melted, right? So lots of buffers, activating, feeding them, all that kind of stuff. So I need to feed them, I need to keep them where they're supposed to be, I need to keep them from getting melted. Yes?
The fluids from the bulbal urethral
Yes.
are they part of semen or are they part of the stuff that comes up before semen?
Depending on who you argue with, both. So some men, it varies, will have bulbal urethral gland will contract before ejaculate. So pre-cum, pre-ejaculatory is here. Some men, though, this only activates when these ones are activated, so it comes out as one package.
So is
So
there,
either one's fine.
so is there actually semen in it though?
You mean sperm?
That's what I meant to say.
No.
So you can't get pregnant from it.
No.
Well, if the second ejaculation and there's sperm left over in the
Right.
urethra, then yeah.
But if you peed once, then no.
There's the key.
But if you,
Yes. So you tell your daughter, yes, you'll get pregnant here. Biologically, you won't get pregnant here.
But you can get STD.
You can get anything from anyone, right? But the idea of sperm being in bulbal urethral is not valid. Hey, question 2. Let's talk about erection, shall we?
You're no fun.
You have videos. All right.
Oh, you're not allowed to.
I can show you anything I want. Let's go back to Mr. Penis Clown. Penis monkey, penis clown, pick, whatever. I just do what kind of finishing clown scared her, and so every time I say penis clown, she has like a breakdown. Right? Let's look at the penis. Alright, so here we chop our penis like a sausage. Here's the rectal tissues. Notice the eyeballs of the clown. That comes out wrong, right? What does it say there? Arteries. So those are your penile arteries or the rectal arteries. So, the man gets excited for valves. His brain tells those arteries to do what? That's what they get big, right? Viagra did that for billions of dollars a year. So those get big. So blood comes into the penis from the heart via arteries. And then what is it going to do with this erectile tissue? What do you think is going to happen in this sponge-like erectile tissue? It's going to swell up with blood, right? So notice the veins. They're in the forehead of the clown. Right? My veins are up here. So when these fill with blood, they're going to push on the forehead of the clown. And what happens to the sides of the veins? The basically they're getting smashed. Blood's coming in, blood's not going out, blood stays there. That's the erection. You simply change the pipes between in and out, and you create pressure, back pressure.
How does blood get to the
There's another vein that comes down. They don't show it. There's another vein down here.
Oh, it's venous blood, not arterial.
I'm sorry, artery. Yeah, all good. So basically, an erection is the difference between the blood going into the penis and the blood leaving the penis. And the size of the vessels determines that difference.
Wow.
That's all there
If you
is.
have an erection for a long time,
You can.
how is it staying oxygen?
That's the problem. So you remember that joke in the Niagara that if you have an erection for only 4 hours, see a doctor? That's why. Because if you have an erection, blood's not leaving the penis.
Right.
What does venous blood carry in it? So venous blood, arterial blood carries waste, right, urea, acids, all these things are deadly to cells. So you have all this CO2, lactic acid, all this waste is building up and not getting out of there. What do cells do? They die. So your penile cells will actually begin to decompose if they can't drain the blood away. It's just like not having blood flow from your arm. So that erectile 4-hour thing, blood's coming in, that's groovy, waste not leaving, not so groovy. Your penis can actually die. They lance it to get the blood to drain.
What do they
Yeah,
What do they lance? I'm just.
basically, it's called a vasectomy. They can basically lance, there's a little, almost like a meninges kind of thing around this called the tunica albuginea. And they just basically lance that, and the blood basically just leaks out. If you break your penis, that's what snaps. That fascia, and the blood leaks out of there into the penis every single time. In case you want to know.
Yeah,
But blood, erections are out, blood going to and from the penis. So there's no bone because you're not a rodent. There's no lung muscle. It's simply blood flow.
So how can it survive? How does the cell survive for 3 hours without?
Not real.
What about 1 hour?
I don't know.
That's just like, like,
First I go down.
where else is your body? Can we go down to 1 hour?
Right. Well, the thing is, you still get some drainage, right? Because otherwise, blood wouldn't be able to move at all. So this is not being totally shut off. They're just restricted enough that blood back pulls. So there's always some. So my guess is you leak enough to keep them alive. But if you keep going, you get this decrease in flow function. But I don't know the actual answer to how long it takes penile cells to die. But over 4 hours, that's why you have to go to a doctor. Pre-prism will actually destroy tissue.
Why does the erection stop after ejaculation? What's the physiological?
The brain doesn't tell the arteries anymore to open up. So the refractory period is the brain just doesn't care. The arteries don't open, and then nothing happens.
This is the rule.
Yeah, because it's actually there's a spinal brain reflex. And the spine and the brain both coordinate erections. And so the brain just simply stops its role. So the spinal cord doesn't care anymore, basically.
What about when you maintain an erection after an ejaculation?
That's biologically not the norm for human males. If you were a cow or a sheep, that would be the norm. Okay, erections and blood flow. What do you want to know? Right? All right.
Which ones are which though? The juice, the eyeball,
Cavernous with the tall eyeball. Sponges around the sponge.
Okay. So they all kind of do the same
They
thing.
all do the same thing. But we'll have that picture. Let me find out one thing. Yeah, so the porous plate. So here's a worthless trivia. Why do you need a tissue here? I mean, you can get an erection with just those two. Protect the urethra, right? So you don't want that to smash. So you expand out so these don't crush the urethra. So that's why you have this one is to keep the urethra from getting smashed by that forehead. Yeah, it's the urethra. So the mouth of the clown is to keep the urethra open, and the eyeballs controls the erection. Never look at clowns ever the same way. Let me show you another animation.
Like the screaming
This is called ASAP science, or little 1-minute animation.
Grown men, little boys, and even happens to males still in utero. You know, the ability to pinch a tent in the morning without any actual camping skills. Now that we've got the wonderful laser away, we can get to the hard facts of nocturnal intumescence, otherwise known as morning wood. It turns out morning erections are part of the normal sleep cycle and occur multiple times throughout the night. The mind and body go through stages of sleep, from non-REM stages, which gradually become deep sleep, finally followed by REM, or rapid eye movement sleep, which is actually fairly shallow sleep. This cycle occurs between 4 or 5 times a night. As you enter REM sleep, not only do dreams occur, but a few physiological changes take place as well. Namely, your brain begins to shut off some neurotransmitters in an effort to regulate your body and in some cases stop you from acting out your dreams. One of these neurotransmitters, norepinephrine, happens to be involved in the control of erections. Specifically, it causes vasoconstriction of penis blood vessels, actively preventing an erection. It's like a stop sign to blood flow. But as you enter REM sleep, norepinephrine decreases and testosterone-related actions are now able to take place.
So back up a little bit there. Remember your sympathetic, parasympathetic. Norepinephrine was sympathetic. Your sympathetic fight or flight, you don't get aroused, right? You shouldn't, hopefully, get aroused when you're fight or flight. So the concept is the brain can use that trick. If I flood you with norepinephrine, I'm going to fight or flight your penis. Penises shouldn't do anything when you're fight or flighting under normal conditions. So now, when you go through the sleep stage, the stop sign, you're disinhibited. The stop sign is removed. Your brain's no longer fight or flighting, therefore, you can now do rest and digest. And that's called the wine and candle thing. So now your penis can work because you're not longer stressed as much, right? That's the concept behind this idea.
The blood flow. But as you enter REM sleep, norepinephrine decreases and testosterone-related actions are now able to take place. This leads to vasodilation, or increased blood flow to the blood vessels, ultimately causing an erection. Why is this important? Well, similar to muscle and other tissue, at night this extra blood increases oxygenation, serving as a system of repair and helping to maintain functionality. But why do we often wake up to this pleasant surprise? Well, we often wake up just out of REM sleep, and as a result, see the remnants of this sleep stage. There's also evidence that a full bladder can contribute to morning wood. The increased bladder size through the night stimulates a region of the spinal cord, which can cause a reflex erection. The physiological benefit of this is to prevent you from urinating in your sleep, but most men can attest to the difficulty proposed by this conundrum after waking in the morning. Rise and shine. Got any question you want to answer? Ask it in the comments or Facebook.
I don't work with them, right?
So science videos.
Right. We're doing okay on male parts so far. Alright, so now let's turn the page over. So now we get the girl parts. Let's go through the girl parts. Same game as before. We're going to fill in the chart together as we go through the curly parts. So again, the order should be roughly that of our A on my way around. So let's go down this here. So ovaries. So ovaries. Let's see. What's their job? Makes eggs. Oocytes, fancy word. So make eggs. What else do ovaries make? Hormones, right? So I want you to stop there and look at testes. Testes are the same thing. They made a gamete, a sperm, and a hormone, testosterone. Eggs are the gamete of female, so ovaries make eggs, and they make hormones. What hormones do we make in a female? Estrogen is one of them, and progesterone is the other one. So the two hormones in females are estrogen and progesterone, whereas testosterone is the main one in males. Same jobs though, we make hormones and gametes. Are ovaries inside or outside? They're very, very inside, right? If they get you to find them. Fallopian tube, aka ovarian tube, oviduct, uterine tube. Pick a word you prefer. That thing there. Okay, what's the job of the tube? Egg highway. Freeway for eggs. Transport. Whatever word you prefer. The egg I-5. So if you get your tubes tied, that's the logic, is again, if I cut the tube, your eggs can't go anywhere. Right? So are your fallopian tubes inside or outside? They're inside. Again, they have to open you to find them. Uterus. Give me a job. Holds embryo, pregnancy, womb, babies live there. Where menstruation comes from, pick whatever concept you want to walk with. Yeah. Organ of gestation, embryological implantation, where cramps are. So, inside or outside? That's internal. Again, you have to, hysterectomies open you up. Okay, cervix. Let me show you a picture before we dive into the cervix. Okay, so you can say cervix, you can say cervical canal. Cervix means literally neck, which you learned in 231. It's the neck of your uterus. So the uterus is kind of a triangle. But you can say cervix, cervical canal. I mean, it doesn't matter how you phrase it. The point is, it has a job. It's part of the uterus. It's not its own thing, but it has a job. What's the job of that little thing there? Right, it's actually a sphincter, believe it or not. What are jobs of sphincters? One-way valve, keeps things open and closed, regulates. So we call it the gatekeeper. In the dark with no finger. So we call it the gatekeeper. It regulates in and out. So this job, it's a sphincter, although formally it's not called a sphincter, it acts as a sphincter, like a valve. Right?
And out of what?
The uterus. So it's controlling what goes in and out from the uterus. So let's figure out, you're supposed to know when your uterus is letting stuff in and when it's not. Let's list those. So, cervix. So when would your cervix need to be open, meaning it's going to let something in or out of your uterus? Menstruation is one time. The blood has to come out. Childbirth. Yeah, that tends to be a time you need to open. And ovulation. Okay, let's stop and ask, why would you need to open that? Let the sperm in, right? Because we're going to conceive, you have to let the sperm toward the egg, which is higher upstream. Childbirth, you have to let the baby out. That's the dilation phase when you're screaming. And menstruation, you have to let the blood out. So the cervix opens and closes to allow those times to exist. So you open and close your cervix to match those. Make sense? So when is it closed? All other times. Why? Why do you want your cervix closed every other time? Keep pathogens out, bacteria, fungi, everything and its brother would love to eat your uterus. Right? It's full of blood, full of tissue, but you want to keep things out. The immunological response. Right? So the cervix is opening and closing to allow these events to occur. Make sense? It's the gatekeeper. Let's keep going then.
Is it internal?
Oh yeah, is it internal or external? Good question. It is considered internal. It's part of the uterus. The uterus is considered internal. It is internal. Vagina. Here's the JJ. What's it for? I never understood why it's longer than this, right? Sounds cool.
for open to say.
Yes. What's it for? Birth canal.
That's who like coined the vocabulary, coined the term.
Organ of copulation. Organ of sexual intercourse. Where menstruation comes out. Pick whatever framing you want to put her on it. I don't really mind. Is it inside or outside? Oh, we don't have a consensus, do we?
Can it be 50-50?
Believe it or not, you're actually correct for 50-50. It is neither inside nor outside because it's considered a transition zone. So the uterus is always inside of you. The stuff down here is always outside of you. That's the way between the two. So silly analogy, is your mouth inside or outside of you? Well, it kind of depends, right? So formally, there's a line about here, but we're not even going to put inside or outside. We're going to ask you a test if your vagina is in or out. It's just a bizarre question. Right? In more ways than one, right? So you could say it's actually both. In fact, if you look again at your lecture text or lab manual, notice they don't put internal, external. They have internal, vagina, external, because they don't know how to answer that question. Because no one knows how to answer that question. It's neither both, neither both. Okay, let's do the labia minora. Minore. Let me show you the picture. So, let's do the graphic. Graphic picture. All right, labia minora. These ones, the inner ones, the smaller ones, whatever word you want to use, the internal ones. What are they for? You can argue protection, that's true. You could say sensitivity, arousal. Look at them both. Feeling, sensitivity, protection, arousal, microhabitat. Big word. So inside or outside? Those are external. You can touch them. You can see them. Okay, majora, the outer ones, the bigger ones. Lateral tube. What's their job? Kind of same thing. In varying degrees. Are they inside or outside? They're outside. Okay, vestibular glands. These actually have multiple names. Vestibular is one of them. Bartholin's is one of them. Greater Bartholin's is the formal one. So if we go on this one here, if you follow this line, which is greater vestibular gland, those two dots, just kind of lateral to the vaginal orifice, those are the vestibular glands or Bartholin's glands. What are they for?
Oh, Bartholin's cyst, is that where you get it?
Bartholin's cyst is one of those, yes. Well, the opening of the glands are here. Those two dots.
Is it for mucus?
It's for mucus, for lubrication. So put down those for lubrication, for sexual intercourse. Here's my graph. So we'll put down lube. That's okay. Are they inside or outside? Yeah, so you could argue, well, I can't touch the gland, yes, but the openings are out on the surface, so we always call them external, even though you could argue, you know, it's like the rectal tissue. So we call those an external thing. So let's go last one. Let's do your clitoris or clitoris. You can say it either way, tomato, tomato. What's the job of your clitoris or clitoris? Sexual arousal. Sensitivity, arousal, sexual pleasure. So is it inside or outside? It's external, last time I checked. Okay. So, let's answer these questions then. Where does ovulation occur? Let's review that word. What does this word with an O mean? Egg. So ovulation, ovary, ovulate, ova means egg. So in English, where do you make eggs? Ovary. You ovulate in the ovaries. Ova, 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 ova. All right. Where does conception, fertilization, they both mean kind of the same thing. Where does that occur? These are the fallopian tubes or uterine tubes. I'm an oldie, I've used this word. So you make eggs in the ovaries. The sperm hits them usually in the tubing, the highway. Right, hit and run. So then pregnancy, aka implantation, where's that? Uterus. That's uterus. Okay, so one difference to keep in mind is males, right, we just make stuff for sperm. But for females, different organs actually have whole different jobs. I make the egg, you raise the baby. It's a whole different delineation. Yes?
What would cause an ectopic pregnancy to rupture?
The fallopian tube can't expand like a uterus, so they always rupture. Almost always. Because the uterus can expand almost unbelievably huge. Fallopian tubes don't. So essentially the baby gets big and pops the fallopian tube open. There's no rhyme or reason. Yeah, so the egg didn't go to here from here. It can be a scar, it can be just genetic, it can be gee whiz, it can be
Birth control. It can
yeah.
the fallopian tube too and go into your body cavity.
Yes, splenic pregnancy, intestinal
You
pregnancy.
can implant everything.
That's right. Babies will stop you right over there. And ordinarily it's an organ with a huge blood flow, like a spleen or intestine, because the baby's sucking the blood. So extrauterine pregnancies, the baby implants in your spleen, or you have a C-section to get it out. That's the concept. Is it just finds place.
inside the uterus, and
That's
so
right.
you actually have to like kind of, it's really hard to surgically remove the.
It is. Because you got to take it out. So okay, those body parts differences. Let's do question 2. Your textbook, your library, everyone says this in every book. The clitoris is homologous to the penis, and the labia are homologous to the scrotum. Okay. You remember from 112? No, you don't. What homologous meant? Same. So it can mean same looking, or it can also mean same structure. So if I rephrase that, the clitoris is the same as the penis, is what the textbook is saying. So we're going to figure out how in the world they can say that. That sounds so cool. No, it's not. I'm going to show you these pictures here. So here you are in utero, 7 weeks along. So you're in your mom's tummy. So tell me, are you a boy or a girl? You have no clue, right? That's why the ultrasounds aren't very good early on. You don't look like much of anything externally. So depending on your genetics, which we'll do hopefully today, is you can either be girl or be boy. You're going to take either the right hand or left hand forward. So as we go along in gestation, at 10 weeks gestation, you look like that. Who's the boy? Who's the girl? Yes, but it's hard to tell, right? So you still look like this. I'm not sure. Can't really tell. So what your body does between conception and birth is it takes the same parts and just basically modifies them to match the boy or girl. So what you're going to do is you're going to do this. So we look at that. So if I take a clitoris and make it grow abnormally huge, we call that a penis. If it stays small, it's clitoris. It's the exact same part. Exact same wiring, exact same nerves, everything's the same. If I take your labia and stitch them together, I have this line. If you wonder why there's a little seam down your penis and scrotum, that's the line where your labia used to be. And then you sew them together, you have a scrotum and a penile shaft from the labia. Remember your testes are on your abdomen. Looks in your abdomen anywhere your ovaries. They're the same part. So that homology word means they're the same piece. You just convert it from boy looking to girl looking or girl looking to boy. So they're the exact same biological aspects. The wiring is the same, the nerve structures are the same, everything's the same. So we took a penis and basically shrunk it down. You'd have the exact clip out the urethra, right? If they did. That's the homology word. So everyone starts out the same, and then you just convert between one and the other.
Is the uterus homologous to anything?
Yes. The uterus basically is, well, it's the ampulla ejaculatory duct segment of the vas deferens. Because the prostate becomes the steam glands, the bulbourethral, the vestibular gland, the seminal vesicle basically becomes part of the uterus. So it's not directly like this, it's not. Makes sense homology? So you basically have the same parts. Okay. So that's what they mean by homologous, or the same. So question 3 then asks this question. So let's learn some parts about vulva. Since people use the word incorrectly, let's teach everybody the words right. So we're going to learn about the vulva, the perineum, and the vestibule, or vestibule. Green orange. Where's my orange? All right, over here. All right, so let's learn some vocabulary. The word vulva, not Volvo, that's a car. Vulva. What does that mean in the real world?
Outside.
Yeah. All right, external female genitals. So vulva is a catch-all for exterior girl parts. So look on your list, you just did. Recite to me the external genitalia that would be part of the vulva. Labia, majora, labia minora, vestibular gland, and the clitoris. And all, you can see it, it's this, basically. So if I put a picture on the screen, one more time. There. So that picture there, now it's graphic detail. If you're looking at the genitalia part, this part here, right there, that is the vulva, the external genitalia parts, right? So then we have that P word, perineum or perineum, you can sort of say it either way. Okay, what is that?
It goes around.
This is, quote, your crotch. So anything in your crotch would be perineum. So the way you think about this is vulva plus what? What else on that picture would be crotch gland but not genitalia?
Your butt.
Your butt, yes indeed. Plus your anus, plus your mons pubis. So if you look at this triangle that's tangent and diagonal, so if you look at that triangle, that's the perineal triangle. So it goes from your mons pubis, basically your pubic bone, pubic hair, goes down and makes this weird looking triangle towards your butt. That is all crotch or perineum. So perineum is the larger structure. It's everything from pubic bone to anus and everything in between. So that's another way to learn it, is pubes to anus. Now some people, like on Wikipedia, will argue about, well, does that include the vulva or is it just the part here, which people call your taint? That's neither friend nor foe. Technically, I learned that's everything. That's how I learned it. That's how the book kind of used it. But people will argue about where your perineum is. They have nothing better to do. Right? Some people argue it's not the reproductive part. I learned that it is. So you can argue with me if you want. So vulva, genitalia, perineum, everything else, right? Plus genitalia. Then we have the other V word, vestibule. Or vestibule. Vestibule means entranceway or beginning of. So this is everything inside the labia majora. So it's not the labia majora, it's everything inside of the labia majora. So if you're going in, which is literally how they think of the word. So name stuff on your list that's inside the labia majora. Menorah, the clitoris, the vestibular glands, the vaginal orifice, etc. So anything that's here in, where it says vestibule, this little brace, that's vestibule, that's going in. Vulva is bigger than that, perineum is bigger than all that. Yes?
This is, you're still talking about external though.
Yes.
It's not considered anything beyond.
Right, so you wouldn't say uterus, because that's not what they're talking about. It's just stuff you can see. So this picture shows perineum as the big triangle, vulva, which is everything kind of in the middle, or it says vestibule, would be the most inner as you're going in. Hence why they're called vestibular glands. Vestibule, they're in the entrance to the genitalia.
What's the part like for when there's an episiotomy?
Episiotomy, what they do is they cut from your vagina, they cut down basically towards your anus. So they cut into this triangle, they're cutting basically, if you want to do it with this map, they're cutting from vestibule to vulva to perineum. They're cutting through all three levels. So they go from the inner wall of the vagina diagonally, or these two straight, they should go diagonally now, like that. Make sense? Those are the words for where you are in this picture. Okay?
What are the holes on, like, the urethra has 3?
Yes! She knows that. Right, so it gets blurry. The word says urethral orifice, that's your pee hole, right? Okay. These two things are called Skene's glands, or lesser vestibular glands. The new word the Anatomical Commission of the World declared was they're supposed to be called the female prostate. So they're a gland that secretes fluid, and they're located just under the urethra. So if you talk about the squirting hypothesis or fight, That's what they mean by female ejaculation or squirting, are those two glands. That's what the big debate's about. Those are called skenes. S-K-E-N-E.
So what would be coming out of them?
They don't know. That's the problem. So the few researchers that study this, they found out it's similar to prostatic fluid, because hence the female prostate homology. But it's not purely prostatic fluid because you wouldn't need to turn on any sperm or whatever. So they think it's similar to, from the studies they've had, it's similar to the vestibular glands, kind of mucus-mucin based, but it has some electrolytes which are not found in mucin. So everyone's in a big tizzy over what it is.
Was it the same stuff that there's like in like lubrication?
No, distinctly separate. And so some people argue, well, it's kind of like pee, sort of. Electrolytes made pee. And people say, well, no, it's different enough that it's not pee. And so everyone's in this fight over do we even ejaculate or not. But that's the fight over those two glands. And that's where the fight is, yes.
Didn't they also discover recently or something that the clitoris is more than just like on the outside and a whole bunch of stuff?
Which is weird because biologists have known that for a century. Right? The clitoris goes miles in there. So, yeah, so unfortunately, doctors don't catch on to very quickly. So the clitoris, the clitoral fluid and bulb is what you see, and it extends down. Actually, the tip of what they call the crus ends up right about here on the tip of your vagina. So there is that G-spot concept, which is if you push the vagina, you push the clitoris, you do. If you go right back here. But yeah, the clitoris actually extends. It's the length of the penis, but internally.
So it's a little penis.
Yeah. Actually, a penis is just a. You just talk about it earlier. So you can argue. But that's what those. Yes.
And so since the clitoris is homologous, is that how transgender people or people who want to become a different gender or the hormonal treatment does?
Yeah. So we're illustrating if I change my hormones, my genitalia gets a different signal, thinking, well, I guess I should go back to the other tips. So, for example, let's see, we'll use this one here. So, if let's say you have this now, right? If you eliminate your testosterone and estrogen, the external part thinks, well, you wanted me to be this. So the penis begins to shrink a little bit, testes atrophy, the scrotum begins to shrink, but they're still there. So the doctor has to basically do some cutting to make them up. That's why you grow breasts. The body thinks you want to be a girl, so breasts are for a girl. So you should, if you're a female, take testosterone, your clitoris elongates and begins to look more and more penis-like. It won't be because your urethra's in the wrong spot. But the clitoris begins to enlarge because it thinks it's supposed to be this option. Your labia begins to hypertrophy to become that. So if you do the hormones, you begin to start changing the externals that match, but they never really match after birth. They just change kind of overall proportions.
But you said the clitoris is like internally just as long as the penis?
Well, not as long. The idea is that it keeps going in inches. Yes. At least that's what they do. Yes.
When they switch, are they functional as the other? Like, can you turn a female into a male and have it be like a working penis?
In the sense of feeling, yes. In the sense of being...
Like erection.
Yes, clitoris get erection anyway, so you can do that. The problem is that the plumbing's off. So you don't have the urethra in the center, right? So that's the shape is different. But you have the same kind of nerve endings, blood supply. So if you just get it to grow, you'll have sort of a functional thing. The hard part is trying to make a penis back in the clitoris. And then make a vagina that works. So what they do is basically start cutting stuff out and trying to make a pseudo-vagina, which is a pouch to receive a penis. But you won't have the same musculature or anything because you can't add muscles that aren't there. Yeah. Okay. So plastic surgeons can do all sorts of wondrous things, but they can't really do complete good. Yes?
So, you know the people who have like androgen insensitivity,
yes.
So they're XY, but they looks like a girl?
Yes.
Female?
Yes.
So how do they still have testes then? Wouldn't they have ovaries if it would just go the same? It would just go to the other side?
Glad you asked. Let's go undo that. Find your packet of pain for a second. Since you're bringing these up. I was going to do this next week. We'll do that today. Find this case study. It's on page 31. We'll briefly go through sexual differentiation. Okay. So this is not a political discussion. I'm not trying to push some kind of agenda, right? I'm just doing this for biology. This case, what do you want? So please do not accuse me of being a shield of male hegemony and reinforcing stereotypes. Okay. So we have different ways you can define male and female depending on what you use as criteria. So if I use your sex chromosomes as the defining criterion, go back to 112. Which hormones do males have? Chromosomes. X and Y. And girls have triple X. So I can look at your DNA and make a call. You have boy DNA, girl DNA, right? We've now learned this. What hormones are mostly in males? Testosterone. So I could say if you have testosterone, you must be a boy, because boys make testosterone. If I were saying you're a female, what hormones would I pick? Estrogen or progesterone. Those are called the primary sex hormones. So your ovaries make estrogen and progesterone. You have that, you call that a female. Right?
What's the ratio on estrogen?
They're about equal, but they split in the cycle. We'll that next week. So gonads, these are 112 words. Gonads are the things that make gametes. So what's the male gonad? Testes. The gamete is sperm. So if you have a testis and it's making sperm, I can define you as a male. Females would be what? Ovary and eggs, or we'll say eggs. Ova. Right. So if you have an ovary making eggs, I can say that's female. From your chart, internal genitalia. You can look at the plumbing. So give me some internal boy parts. Prostate, your seminal vesicle, the vas deferens, epididymis, everything on your chart that has an eye could be defined. So if I look at you, you have a prostate gland, I can say, well, you must be a boy, because boys have a prostate gland. If I were female, what are some internal parts? Fallopian tubes, uterus, obviously, right, etc. So I could look and say, hey, if you have a uterus, you must be a female. That's one internal genital. Make sense? External genitalia. All right, give me some boy outside parts. Penis tends to be what comes to mind, right? Scrotum, penis, those tend to be boyish. And girl parts would be, I used to say vulva to shorten it, but clitoris, labia. I could say that if you have a clitoris and labia, you must be female. Okay. Does anyone remember from sociology class what a secondary sex characteristic was? Yeah, these are things that are not the body parts, but what you associate with it. So maleness, facial hair, right? Back hair, chest hair, fat distribution. So for females, you have lack of hair, you have breasts, you have hips, right? Higher voice in men, higher voice in women, lower voice in men. Those kind of things. Things you associate with male and female, but they're not the parts per se. Then if you want to get in a fight with people, you can bring out that there are behavioral differences between males and females. You don't want to posit one, possibly?
No.
Aggression. Some people may be competitive, aggressive. What about females?
Supposed to be like better communicators.
Communicator, warm fuzzy. I mean, you can argue all day long if those are true or false, right? That's not the point of this discussion. But you could go through and define male and female a whole variety of different ways on how you think males and females are different, right? So the trick is these next questions. So if I was asking what determines your chromosomal sex of a child, what determines your chromosomal sex? When I wrote that in. The chromosomes you get. So you did this in 112. If I get double X, I'm a female. If I get XY, I'm a male. All right, harder question. What determines the physical sex of a child? How do you know it's a boy or a girl baby?
Internal or external?
The genitalia. Usually, for most parents, you look at what's between its legs, right? And the harder part, what determines if it's a boy or a girl socially?
What is your internal?
Yeah, I'll let you figure that one out, right? But as a parent, before, My kids are different. I know them when they're babies. How they act is different. I can't put my word on it, but there is a difference in boy and girl behaviors. Right? You can fight all day long whether you believe that to be true or not. Okay? But here comes the problem. What makes that occur is this stuff. So we got some science here to learn.
So when, I mean, if you have an intersection test, if a surgeon is determining how to.
Yes.
Is there like a grading scale, a point system on?
It depends on the surgeon and the parent. There are grading degrees, but it's basically an old school approach.
I don't think they do that as much anymore.
They don't do as much anymore, they're not supposed to. You'll still find parents that really want to boy. But there are like, you're more boy than girl, more girl than boy. There's also.
There's no like formal, like, well, you get 2 points for an ovary.
Yeah, I don't think anyone does that. You get a C for your forward. I don't think anyone does that. That's one of the controversies, is how you determine if something doesn't fit one of the categories. What do you do? And that's where this intersectional problem comes in. So take a look at this. This is some science for you. Let me show you what they're talking about. This goes back to that homology concept. Remember, in homologous, they're the same. So here you are in mom's uterus. You have tubes and gonads, and they're neither male nor female because you're not yet a boy or girl, right? You're both or neither, depending on how you view it, right? So you have these things called ducts, Mullerian and Wolffian. You have 2 sets of tubes and some gonads. And you can take those tubes and make a boy or a girl out, depending on choices. So let's look at this. If you become a male, the gonads become testes will descend. The tubes will become the boy tubes, vesicle deferens. The other tube vanishes, goes away, because that's the girl tube. So I'm going to keep the boy gonads and the boy tubing, and get rid of the girl tube. If I'm a female, reverse it. The gonads become ovaries. I keep the red tube, which is my uterus, ovum, cervix. The boy tube vanishes. Right? So you're picking one set of choices over the other one. Right? So that's what they're talking about in all these tubings, is which tube you keep. So if we go back to the case study, here we had a female leaded rats, and they had the 2 ducts, Mullerian and Wolffian. And what they did was they took out the ovaries of one female rat and let the ovaries in the female rat. Okay? So to get your bearings, men are dogs, right? The word wolf is the male tubing. So remember that men are dogs. That will tell you what we're doing. So if you're a female rat, you keep the girl tubing on. You turn off the boy tubing. That makes me a normal female. Does that make sense? I'm going to build ovaries, uterus, and all that. If I take out your ovaries, tell me what the effect is. Are you a boy or a girl?
Still a girl.
You're still a girl. You don't turn on boy, you live on girl. Why does that make sense to placental mammals? I think why you always build a girl.
Because there's no SO1.
No, true. And who has babies? So biologically it makes some sense. If I don't know what to make you, I'm going to make you a girl because girls give birth, right? So evolutionary makes sense. If I'm not sure, if you're missing a part, I'm still going to make you a girl just in case you can reproduce, right? Because boys never reproduce in terms of biological value. Make sense? So we call this the default position. You're always a girl. Your body doesn't know. I can manipulate that by finding a boy rat here. Normal male, I turn on the boy tubing, Wolffian's on. I turn off the girl tubing. Make sense? I cut out his testes. What do you see? Oh. He became a girl. Because again, if I don't know, I want to be a girl. Girl's default for placental mammals. So if I take out your testes, your body thinks, oh, I should go back to being a girl. Because that's what I'm supposed to be unless you tell me to be a boy. Make sense? So then again, they call this girl default. So boys are an option. Downgrade, whatever words you want to use politically, right? But if I don't have testes, I'm going to become a girl. Because girls are important for reproduction. Females are males. Make sense? Right. So X and Y. So let's conclude. Testes. So are testes necessary to become a male? According to this. Yes, if you take out your testes, you become a female. So to be a male, you have to have testes tell your body I'm a male. Make sense so far? Logic. Okay, so then we have this next experiment. I'm going to let you look at this data table. Now they manipulated the testes and the hormone made by the testes, testosterone. I'm going to give you 2 minutes to look at that table and try to figure out the role of testosterone in making a male. Take a look at that. Tell me what you think. It's a little bit of science thinking. From this data table, tell me about the job of testes and testosterone to make a male, according to the data. No. I need both, right? To be a normal male, the only normal male is this one, because I'm all male, no female. If I take out testes, I stay female. If I take out the testes and give you testosterone, what does this mean? I have both. I have the female plumbing and the male plumbing. If I leave my testes in and don't have testosterone, I am neither. Right? So to be a male, you need 2 things. You need testes and testosterone to be a male that's functional. Right? But you're not done yet. Let's see if we can figure out why you need 2 things. According to that data table, what's the specific job of the tubing in relation to the testes? What are the testes doing to your tubing? Can anyone catch between these 2 choices and these 2 choices what the testes are doing?
Making the other ones not develop.
Very good. So testes turns off the female ducts. So if I have testes, that tells my body to not build the girl tubing. But you're supposed to not be girl. So therefore, what does testosterone tell my body to do? Turn on the male. There are 2 things I have to do to be a male. I have to not be a female, and then build a male. I need both those, because let's look at the data. If I take out your testes, that means I'm not going to turn off the girl. And I give you testosterone, that means I'm going to turn on the boy, so I'm going to be both. If I leave my testes in, that turns off the girl. And if I don't have testosterone, I do not turn on boy. So I have neither set develops. Bothersome yet? So to be a male, we have to have testes and hormone to make your female parts become male. So, question number 2 from biology 112. Which of those chromosomes is the male chromosome, X or Y? Y. That's the Y chromosome. So the Y chromosome is supposed to do this. So the Y chromosomes, you learn in 112, is what's supposed to tell your testes to turn on and turn off the girl, and then make testosterone to turn on the boy. That's the Y chromosome. So let's go through this, which you did in 112, which is a class. Please, 112, the non-disjunctions. Not at all. Okay. If you're XY, what are you? You're a male. The XY individual should be a male. And you are a male because you have a Y chromosome that makes you do those. If you're double X, what are you? That's a female. Cool. Okay, here's a harder one. Turner XO. What were you if you're XO or just one X? You're a female. Why aren't you a male? Because you don't have a Y. Y makes you male, defaults female. So if I don't have a Y, I have to be a female.
Aren't they also like short?
They tend to be shorter, they have a webbing on the neck, they have a kind of round chest, they tend to be sterile, there's some other anatomical things, but they basically look female-ish. They have the internal plumbing of female. So, X double Y. You are a male. It's called a metamale. Because I have Y chromosomes, I would then do this. It's called a metamale or supermale. Yeah. XXY. Male. It's called a Klinefelter male. We have a Y. Triple X. That's a female, meta-female, or super female.
What do you get extra with a super?
They just say that. You don't get anything better. In fact, what's weird is the more X's you have, there's no problem. Triple X females and quadruple X looks the same as a double X. Extra Y's make you look weird, but extra X's don't.
What do you get if you look weird?
X double Y males are usually taller by about a foot of most people, so they're like in the 6s. They tend to have very kind of long limbs. They have a very deep voice. They have a kind of elongated face. They have you don't want to say mental retardation, but they tend to be on the lower end of the
Like Andre the Giant or whatever?
Yeah, acromegaly, but similar. Not as big overall, but taller and just slower than. I don't mean to say it in a mean way, but not the brightest guy on the street.
If you have double chromosomes on the nannies that you get from your parents, will you automatically have those on?
Only if they're meiotic, and then not every time because you get only one. Depends on which part non-disjunction you get. How about OY? Just the Y. You do not exist. Because just the Y, you have to have an X and a Y female, not just a Y. That's 112 review. I'm never asking you that on a test. Right? That's the meiosis. Alright. So go over to number 3 on the next side. Alright, or sorry, number 2 actually. So, we need to figure out what it takes to be a male. And the Y chromosome contains a SRY gene, and that's what this is. It's called an SRY gene. Remember 112 genes are in chromosomes, right? So instead of just the Y chromosome, what we're looking at is that gene that's on the Y chromosome. That's what does this. So let's take a look. Suppose you're a double X person. So genetically, what are you if you're double X? Female. And I give you an SRY gene. What will you be if I give you the Y information on your X chromosomes? You would act XY, which makes you what? You'd be male. 100% male. Because you would get the Y information that does this. You would look male, you would act male, you would be male. Genetically, you would be a girl genetically. But you'd be a male in body. Scared yet? Okay.
Can they stop that, or can they remove that at, like an 8 at birth, so to speak?
No. I mean, every cell of your body would have that.
And you can't block it?
Not easily, no. I mean, you can, just, you'd have to go through those hormone replacement kind of thing. As all his birds, you'd be perfectly normal looking male. You'd have sperm, and you just, if I did a blood test and say you were a girl. So if you kill someone, they look for a girl. You'd be a boy. Yes.
Do these people, do they feel like they're in the wrong body?
No. Well, they're not. They're a perfectly normal body. It's just they have an XX chromosome.
Can they pass it on to the baby though?
Yeah.
Like Y chromosome?
Yeah.
So even if
They ask for Y, you can pass them.
oh.
So let's do this one. If you're, yes.
So they could pass on the X chromosome that has the Y
Yes.
effect on it. If that's combined with another Y chromosome,
Then that would be inviable. Because, well, no, actually, it would be a meta male. You have a double Y. So it'd be an XY individual, but you'd be acting as if you're a double Y. Because you wouldn't. Let's do this one. Make you really nervous. An XY person, when I took the Y gene off, what are you going to be? You're going to be perfectly normal female. Because if you look on your sheet, right, the Y makes you male, X's don't. X's make you female. So you would be basically a Turner female, be like an XO. You'd be female. Here's a bother, yes?
Increase your chance of like genetically inherited diseases, like ladies getting hemophilia.
Yes, you could inherit a male disease by inheriting a Y. So this person could get a Y male disease. This one would lose any Y-based disease. I took the Y away. So only of those that are sex-linked. So let's give you double X, but I give you testosterone in utero. Or your mom took steroids at the gym while pregnant. What do you think is going to be happening to the person's disease? Let's go through it. They don't have a Y chromosome, right? Their body doesn't do this. So if I don't do this, I'm going to stay a what? Female. But I give you testosterone artificially. Testosterone by itself does what?
Turn on male.
So tell me what I'd be if I... Oh. You are intersex. You would have both sets of plumbing, or possibly both, because you didn't build male. You left girl on and added boy.
So like female bodybuilders, if they get pregnant, are they more likely to have?
Not statistically, because a lot of them are amenorrheic, but in theory, if you were taking steroids in utero, then you could have this happen.
Or if you're just a female with more testosterone.
Right. This happens in cattle. Worthless trivia. Kind of free marketing cattle as a farmer. If you're a girl twin of a boy cow, his testosterone does this to you. His testosterone basically skews you into your infertile female, so you always get sold. Because you would not build all the girl parts in addition of free markets. Worthless trivia. So let's do Terry here real fast. So we have Terry. Let's just go down to the doctor. Let's bring a normal looking female, so she looks like a girl. She has XY chromosomes. Does that sound like a normal combination? No. That's a boy genetics, but she looks like a girl. Let's keep reading. They found testes in her abdomen when she was a baby. So let's review what testes do. What do testes normally do? Testes turn off your girl. They should make testosterone to turn so that you should be boy, right? But she looks like a girl, but she had boy information. So let's look at that. She had no girl plumbing that developed. She had no boy plumbing that developed. So they had to give her estrogen to make puberty happen. So let's see if we can explain that. No girl plus no boy means what? What happened to her as an infant that made her be neither? She had testes. That's the answer. She had testes, which turned off girl, but she never became a male because she never made testosterone or testicular feminization. So her testes said don't be a girl, but she couldn't turn on the plumbing to be a boy. So she's neither. Both have one argument point. Right? She didn't complete the other option. Make sense? So she would look like a female, but she would not have turned on the male plumbing. Yes.
Is that because, so this person had testes like up until shortly after birth?
Yes.
So when you were an infant. So that would have turned off the girl
yes.
part, but then when they were removed, that meant that they didn't develop. And I'm confused about what, like what.
So what happened was, if her testes were working in infancy, she would have had no girl and all the boy, right? So she had testes which seemed to turn off the girl, but they never turned on the boy. So her testes did only the first job. So when she's born, she had testes and a girl body plan. So it made her a girl, but not a boy. Because that's what happened was the testes were not. So what's happening is she basically turned off the girl in utero, didn't build boy. Her parents then gave her estrogen to kick in puberty so she looked like a girl. But genetically, she's not a girl. She's a boy. So she never built her boy body to match the genetics.
So what would happen if they left their testes in and then later